we did elephant toothpaste.
And so you need dish soap, food coloring, hydrogen peroxide. This is 6%, and then this is 3%. And so we did 4 tablespoons of the 6% in there. We did 2 tablespoons of 3% and 2 tablespoons of 6%, and it made it 4.5%.
Alright, what's happening is the yeast and the water, it acts as a catalyst to this, and the dish soap traps the oxygen bubbles that is in the solution, and then it foams up and it looks like elephant toothpaste.
Okay, so now we're gonna pour the yeast. We put water in it into the solutions and see what it does.
Alright, this is the 6% and it has the
Let's start.
Yay!
I just kind of changed the color. I made it a little foamy.
Yeah, it got a little foamy.
Okay,
Alright.
so
This didn't really work, so we're gonna add some more water and yeast to see if the reaction gets any better. Alright. Alright. Oh yeah, see, it's bubbling up more. Almost to the top.
mine's still the same.
Well, the 6% is bubbling up.
And the 4%'s kind of staying the same. Yeah. But it does get hotter.
Yeah, it's
It's getting warmer.
Okay, so I did the copper sulfate and aluminum foil experiment. That's what I'm doing. So I'm going to put this aluminum into this solution of 20 grams of copper sulfate and 200 milliliters of water. And as you can see right now, kind of, it's not bubbling or changing color or anything. So I'm going to add salt, which is the catalyst in this experiment. And now, hopefully you see something. Okay, alright, it's bubbling. Can't really see it, because up close you can see it. And it's floating, which is great. And the color is turning a little greenish. Let's see, can't really see much here. Yeah, so you can kind of hear it bubbling up close. So why it's coming out of the thing. So if you get up closer a little bit, you can see some copper colored metal, and that's happening because when you put the salt into the solution, the salt scratches the surface of the aluminum and it takes off the aluminum oxide that's on the aluminum foil, and then the chloride ions react with the aluminum and it turns into a copper metal. Oh, there's some copper at the bottom. Yeah.
So I am doing an experiment with temperature and reactivity. Temperature is basically how energy, how much energy it has or the lack thereof. And here we have a cold bowl, and here we have a hot one. The hot one should be a lot faster than the cold one. Now we shall put them in to the chemicals, which are calcium chloride and baking soda, which bubble and they meet because they are moving energy around and are changing up their molecular format, such as turning into carbon dioxide, which causes the bubbling. We gotta wait like 10 seconds. Alright. So, let's see how fast the cold one happens. Doesn't even do anything at the start. You can see very, very little bubbles. And with the hot one, immediate reaction. And it is everywhere. And not just that, it also ends very quick too. This happens because one, the molecules are moving around very fast and very much, and they are also unstable, and when things are unstable, they tend to be able to break apart more and even move more. However, when they're cold, they barely move at all. The atoms are barely even touching each other. And the cold one has just started. It'll probably go on for another minute before it finally finishes.
So for my experiment, I'm going to put a straw in this cup full of universal indicator solution, which tells you how acidic or basic something is. And if I blow into it, it's going to turn really acidic because the carbon dioxide in my breath will bond with the water inside it, and it will make carbonic acid. And this is the chart that shows you where it is. Oops. So now it's like a 1 or a 0, which is a pretty acidic solution. It's like orange.
Okay, so our experiment is instant ice, and the way it works is you have a 16.9 ounce water bottle that will be cold below 0, but will not freeze. Most likely. Anyway,
So what the water is it's a super cold liquid, and since it's a body of water and it's pure water, the water doesn't have little microscopic particles to grab onto and to grow in a crystal pattern. That's called nucleation. So let's go ahead and see if they're ready.
so the temperature right now is negative 10.3 Celsius, negative 10 Celsius. Anyway, so what we have is we just have ice cubes and rock salt. So the rock salt helps, I think, contain more of the temperature. And so what we have is we've had these water bottles that are sitting underneath the ice, which will cool them but not totally freeze them. So what we will do is we will get one out carefully. Otherwise, if we are not too careful, if we take it out, it'll freeze before we even get it out most of the way. And what we're hoping to do is get it out and like knock it, and it'll freeze from the top to the bottom. And it's not exactly ice; it's more of like slushy snow. So we're now at negative 11.6 Celsius. And
So the reason we need to hit it is because that like kickstarts the whole experiment, and it makes it so the water has the super cold liquid water has those microscopic particles to grab onto and grow off of. Are they ready?
I think they're pretty much ready. So what we're gonna do is we're gonna
Do one at a time.
do one at a time. So if we mess up, we try the other one. So remove the ice.
Oh, it's cool.
And now
Just make it on the table.
That's cool.
it's not cool enough.
Shake it up. It's not cool.
It's not, so put it back in. Is it freezing?
Okay, now our temperature is at 14.6, negative
Negative
14.6 Celsius. What we're gonna do, since last time didn't work, and we're gonna get the one that was been here the longest. And
There's some ice starting to collect in there. It froze a little bit.
Gross. Pull the other one out and try it.
Yeah, it only froze a little bit. Maybe if I blow it on yours. Nope, it's not cold enough.
so
It froze a little bit at the top right there.
So it did collect a little bit of ice, but not much. It did not do exactly what it's supposed to. So
Okay. Whoa!
that was cool.
Is that what's supposed to happen?
Uh-huh.